Hi everybody! We are continuing on with our chapter about energy, work, power, and simple machines, chapter 6. We are going to be starting on a new section today because you guys just had your quiz. And this section is called Work and Power. I had to insert this GIF because it was too good. I couldn't not put it in there. So we're going to be talking about work today, and we're going to be talking about power during our next class meeting. Okay? So, work. You might think that what I'm giving you is work, but in physics, that is not what work is. Work is very specific, and the definition is the transfer of energy that occurs when a force makes an object move. Okay? So, we're exerting energy and we're applying force, and the object is moving. So this would be at a time in class, if I was with you guys, where I would go up against the wall and I would push it really hard and I would really tire myself out pushing against a wall. And I would ask you guys, is the wall moving? And what would you say? No, obviously it's not moving because I'm not the Hulk. But if you're pushing something and it's not moving, there is technically no work being done. Yeah, you're exerting force. Yeah, you're using energy. But technically, since it is not moving, you are not doing work. And work has to be done in the same direction that force is applied. So, another example would be I am carrying, let's pretend that I'm carrying a stack of books. Okay, I'm carrying the stack of books. My hands are beneath the book, okay, beneath the books. So I am pushing upward on the books, okay, to keep them from falling, obviously. I'm pushing upward on the books. So that is the way the force is going. The force is going up because I'm pushing up on the books, keeping them up in the air. So let's say I lift the books up from the floor. I'm lifting them up. So my force is going upward and the movement is going upward. So the books are actually moving up. But let's say I have the books in my hands at the same exact height and I start walking around the room. That is where it changes because my force is still going up, okay? My force is under the books and it is still going upward. However, the motion of the books are moving around the room. I'm not pushing the books around the room. Okay, I'm still carrying them, and the force is still going upwards toward the sky, but the movement is not going upward. Okay, so that is again not work. If I had a book and I was pushing it around the room on the floor, that is work because I am pushing the book with using force around the room, and the book is also moving around the room. So work has to be done in the same direction that force is applied. Okay, so this was the example that I just gave you. So you pick up books on the floor, your arms are doing work on the books. You hold the books while standing. You are doing no work because you're unmoving. You walk around while holding the books. There is no work on the book. Oh, sorry. There is no work on the books because you're holding the books upward but walking horizontally. Okay, so I will probably post a video demonstrating this for you guys. Work is a transfer of energy. So energy can be transferred to an object by doing work on the object. When you do work, you are decreasing your own energy and giving it to that object. So this is what makes us tired. This is what burns calories, okay? So we have energy in our bodies from the food that we eat. And when we do work on things, when we push things, when we pull things, when we move things, even if it's a tiny pencil that you're picking up to do your homework, you're doing work and you are exerting your own energy. You are burning calories. So you are moving that energy that you have in your body into the pencil to make it move, like kinetic energy. Let's say you are pushing pushing a sled. No, that's a stupid example. Pulling a sled. Okay, let's say you're pulling a sled, and you have someone on it. It's wintertime, and you're pulling a sled. You are transferring your own energy from your body into that sled to make it move. That sled did not have any energy before you touched it. And now you're taking your energy from your body and putting it into that sled to make it move. Again, we have a nice little formula here. So work is done when a force is applied over a distance. So it has to move. That means over a distance. Moving means that you're moving over a distance. Okay, so work is force times distance. That's it. So W equals FD. And it is measured in joules, just like energy, because work is technically energy. So work equals force times distance. So we will practice. You move a 75 kilogram refrigerator 35 meters. This requires a force of 90 newtons. How much work in joules was done with moving the refrigerator? Okay, so you have your distance, which is 35 meters here. We know meters is distance. And we have our force, which is 90 newtons. Is there something in this word problem that is irrelevant, that we do not need? Yes, we do not need this. 75 kilograms, who cares how much it weighs or how much mass it has? We do not need this for our purpose, okay? So you need to be able to extrapolate the pertinent information from these word problems. So we have our distance and we have our force. So all we have to do is multiply them together. We have our distance here and we have our force here. 35 times 90. 90 times 35 is 3,150 joules. Now we are going to practice. I'm going to pause you guys and bring up my paint so I can do a practice problem with you. Okay, I am back. So our practice problem. First, let's draw the whatchamacallit, the formula. So we have weight equals force times distance. Now, I believe you could do the triangle here if you need to. We have weight, we have force, and we have distance there. So it's just like the F equals ma. So did I just say weight? I meant work. Work, force, distance. Am I saying weight? I'm so sorry. Okay. Work equals force times distance. So let's think of a problem. You are exerting 5 newtons on a book. You're pushing it a distance of 10 meters. Okay, so how much work have you done? So our force is 5 newtons and our distance is 10 meters. You simply have to multiply 5 times 10 and you will get 50 joules. Okay, so that is how you do these problems. Now let's try doing a different problem. Hold on. Let's do a different problem. We have our work, we have our distance, and we have our force. Okay, so let's say you are doing 35 joules of work. Okay, we're doing 35 joules of work. So notice I'm starting with work. So it's not going to be the same formula. You're going to have to use this. Okay, so we're doing 35 joules of work, and we are doing those 35 joules of work over a distance of 5 meters. Okay, so we're doing 35 joules of work over 5 meters. Now, according to this, do you need to multiply or do you need to divide? Think of how to use the triangle. So if we're talking about there, that is multiplication. But we need to find force, okay? Force. We need to find force. So we are going to look at these two variables. The W is on top of the D. So it will translate to this, work over distance. So let's apply these variables to this formula, okay? So we have 35 joules of work over 5 meters of distance. 35 divided by 5 is 7, and that would be 7 newtons because we're dealing with force, okay? I know it's confusing, and I know I wish I could be there with you guys, and oh, this is not what we were just doing. Okay. I wish I could be there with you guys, but unfortunately I can't. I'm going to try to do office hours again tomorrow at some point, today and tomorrow. So please let me know if you have any questions. Email me if I don't get any responses for office hours. I'm not going to do it. So please respond and show up. Okay, so email me if you have any questions. Also attend office hours. Otherwise, I hope you have a good day.